Hi everyone, and welcome to day 11 of my 65 days of TypeScript challenges. Last week I looked at the includes challenge, which you can see on the homepage of the TypeScript challenges repo. It's over there. And I feel like I cheated because in my solution I use another utility type, but I think the spirit of these challenges is to completely implement the utility type that we're meant to implement without relying on any other utility type. So what I'm going to do is quickly write up the solution that we came up with, highlight where I have used the extra utility type, and then take a look at the utility type we're using, which is the equal utility type that's being used in the test cases over there, and break it down, understand it, and then replace basically rewrite my solution to use that to use my understanding of that utility type. So first things first is problem statement was we have some array of types, some tuple, and we want to check if the type on the right hand side is included in the tuple. The structure that we chose, that I chose, was to first of all go through and first of all to create a Boolean tuple, right? A tuple of just Boolean values where each index says whether or not that the value in that index is equal to the type we're checking for. And then the next step was to unionize all of those. The reason being if there is okay, no. The next step would be checking whether we have a value in there. Oh, yeah, unionize actually. Wait, what's the logic here? So if, say for instance, we're looking at cars, if cars is included here, what we'll get is a boolean that has in this index true, and then false, false, false. And what did we want to do? So if, okay, how about so I think I decided we invert it, right? So if it's in this tuple, we return false, else we return true. So at the end of the day, we'll either have a tuple that's completely true, and then when we unionize, find the union of all those values, we have true, or we, what do you call it? We have false. If we have false, then it would mean in this case that we're looking for true. So yeah, let me just code this out. First step is we're going to loop through, what are we doing? We're going to loop through the array t. So t in key of t, we are going to check if tt, the value at t, extends u. Now this is the rough way of checking the equivalence of types just using extends. If it does, we've told ourselves that if it does extend, so for instance, if cars extends cars, we want to return false, not true. Else we want to return true. Okay, now the next step is we create a union of all those values, and we check if that extends false. If it does extend false, if the union of those values is false, then isn't this what we want? True, false. I think that's what we want, but if that extends true, yeah, I think that's what we want. And finally, when we take a look at the test cases were failing, so let's see, the test cases were failing. Cars is in cars. 7 is here, 2 is here, and so on and so forth. So we shouldn't be failing these test cases. Something's wrong. Okay, so let's break this down again. So type tuple array takes the exact same things this takes, and what does it do? It just does the first part, which is what this is doing. And then we can replace all this by just saying tuple array passing t passing u. Okay, and now we can test the output of tuple array with one of these cases here. Let's copy that in and see. Oh, it's giving us, yes, it's giving us a Boolean array false, true, 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 like we want, right? And then when we create the union by just using the syntax for looping through a tuple, what do we get? Oh, we get Boolean. We get Boolean. That's interesting. We get Boolean. I was hoping we'd get a single. Oh, Test becomes Boolean. How can we make this specific? And what do we get if? I mean, I'm guessing. Just want to see what we get when we actually use includes. So includes, again, this input rather, right there, and what we get is false, whereas we are aiming for true. And I'm guessing no matter what value I put here, it's going to be false. Yeah, it's going to be false. So it's false no matter what. Okay, so the issue here is this is too broad. I want to actually create the union as okay, wait. Is there any way I can force this to be specific? I don't think that works. What did we do? What did I do last week? So tuple array. Think of t extends u. If it does, return false. If it doesn't, oh, how about never? And what do we get now? False. Okay, cool. And what do we get? False. We still get false here. And when we change it, does it give us the correct thing? How about now? True. Okay, cool. I think that's better. So what's failing? A lot of stuff. A lot of cases are failing here. So with Dio, what's going on here? With Dio, do we get false? Do we get true? Do we get never? Okay, we get never. extends false. Okay, if it extends false, how about we check if it extends never? Can we do that? We can access inferred types. Can we infer? Well, why? Anyway, if it's why is it failing? It's returning true because never extends false. I'm very tempted to just look at what I did last week, but this is interesting. It's like I'm going down a completely different, well, not completely different. I think I'm going down a significantly different path from from what I did last week. I mean, last week I got a solid answer by converting this to a perfect equality statement. So that means I did something else, something different here. I don't know. If it extends false, return false. I'm going to try and swap this. So TLC extends you, then true, else false, and then in terms of the union, well, true, else never. And if it's true, else false, it's the exact same thing. This will return never. Never will extend a boolean. You can never assign anything to never, so a type of never. But I didn't know you could. If that's the case, how does never extend boolean? How is that possible? Type. Let's see. Of type never. Yes, value false. Okay, so why does never extend boolean? So weird. If tuple val at this case gets never, let's leave it as array, gets never, and we're checking if never extends true. Type never extends true, that should always be false. So why does this give true? Oh, yeah, because never doesn't extend true. So it's true. Let's be very specific. If it extends never, then it's false, else it's true. Okay, there we go. I wonder if last time I didn't have to use never. I'm sure do we need to use never is the question. So if it extends true, yeah, we went through this, right? It would return a boolean value. Let's see. Boolean false. So does this return a boolean or not? It doesn't return a boolean. I see. Okay. So I think before we returned a boolean because we could potentially get true or false in some way. I can't remember the exact case. But this, so what's the logic? Initially we're inverting to false, but now we're actually just checking if u is in the array, return true. If it's not, return false. That gets converted to a tuple of either true or false, and then we get the union of the true or false values, and if there's any false, it will always be false. I'm really glad about that. I'm glad it doesn't resolve to a boolean, and then we can check if it's a false, then we know that the value was whoa. If it's false, oh yeah, so if it's all false, I see. So if it's all false, then yes, we get false. But if there's any true, it becomes boolean. So if it's all false, then and we see false, then we know that there was no case where it was true, and then else it's a boolean. If it's a boolean would extend. Does boolean extend false? Apparently not. That's the key thing, maybe. How do I test that? Okay. Something like let C of type false. Interesting. Guess very true. Yeah. I think that is good enough to tell us that it doesn't boolean doesn't extend false. Okay, well, good. We're back to where we stopped last week. The last time I was here, and today I'm just focusing on how to do a proper equality check, right? So last week this is so weird. Apparently boolean extends true. Wait. Does that mean I can do this? No, it doesn't. Oh, expect this to be false. Okay. Oh. Oh, okay. Well, I think I saw this as well last week. I can switch the order. U extends T of T, for instance. And you'll pass those, you'll fill some others. Yeah. You'll fill some others. So why is it that a strict equality helps us because we can check exactly whether boolean is equal to true rather than one extends the other. So rather than doing this, I did equal, equal taking the actual particular value and u, and what else? Equal, we don't need to do that. and we modify this test case, right? So this was false boolean. Boolean is not false, so this should be false. I think the case was a truthy case, so I don't know. This should be false. I don't remember the exact test case. Let me go back. Undo. Okay, there was false, false, true. Okay, that's all. False, false, true. Let's leave the test case as it was. So yeah, in terms of today, I want to look at how equal works under the hood and just try and understand it. So let's go to definition. Okay, that didn't work. Let's pick definition. And I remember looking at this last time, and thinking, okay, what exactly is going on here? I don't know, right? But we're taking x, y, and t, we're creating some utility function. We are running a function, a generic function, that checks if t extends x. And if the output of that extends, whoa, how is this in the type space though? Okay, anyway, I'm checking if that extends, but what I don't understand is how t is getting a value. So let's copy this, close this, import expression expected. What have I done now? Oh, there, I see. Okay, cool. Remove that. I'll define a type custom equal and use custom equal. Okay, let's play around with this to try and understand it. I wish there was some way in TypeScript to see the values types take at each point. Can you do breakpoints in TypeScript? Outside of Visual Studio, let's see in the playground. I mean, there isn't anything that's jumping at me, so I'm just going to leave this for now. How do I understand? How do I figure out what's going on here? Let's see. Close some tabs, close some tabs. To the best of my knowledge, this no, let's break things. Let's add L. L is declared, but its value is never read. Type parameter L in TL returns a type. Does this return a type? Checks if T in TL T extends X. Can I do T extends Y? I can access y, I can access x, I can, what does L extend? L extends x. L works as expected, that's interesting. J extends x. Still works as expected. I mean, basic understanding of this is but does it extend y? It looks like some type. If I were to design this and I were creating some random type t, and checking against x, checking against y, what would t have to be? Some sort of output type? What exactly is this syntax anyway? I wanted to define a property that was a function that returns something. I would probably define it like that. A generic function that returned t. That's how I would return it. That's how I define it. Generic function that took t and did stuff with t and returned t. How about t extends x? Thankfully it complains. It says cannot find name x. So when I execute this function, what is the default value of t? I think it's any. Does any extend x? Let's say x is the string hello, and we ask ourselves, does any extend hello? Yes, any extends hello. So we return 1, and then we ask ourselves, does any extend, let's say y is world, does any extend world? Yes, it does, and so we return 1. Does 1 extend 1? Okay, so we shouldn't return true in this case, because hello is not equal to world, so it's not any. But what should it be then? It's some generic type. Looking at let's remove the equal from here and go back to t extends u true else false. When we look at what's going on here, on the right hand side we have a read-only property A with value A, and here a standard property A with value capital A, and that's X, that's Y. In the first instance, I want to see what happens. Let's start. Let me just copy here. I just want to see what happens to the type as we go along. Oh, I forgot to do this. And let's copy in that. Okay. Delete this. I can also delete this. C gets the value C start. Let's pass in that on the left hand side, and let's pass in this on the right hand side. Maybe I'm tired, but I think this should be obvious. But I think it's just at the back of my mind what X t might be, but it's not coming up. So let's continue debugging. What we get here is that t extends right. Why don't we get 1 or 2? Why do we get the whole expression? So no matter what X or Y values we pass in here, this type will always be, this type will always be of a function type that takes the first value and plugs it into X. So what we will get here is, yes, X is expanded. Why is that useful? C first, let's see. Okay, let me just do that over here. Type C continued, takes X, Y, and then again this time we're plugging in the Y value, and let's test that that's the case. Type C continued. Okay, cool. So now we have Okay, awesome. Now we should have read only. Okay. So the question then becomes, does t extends this return 1 or 2 extend t extends read only? Okay. So this is working completely differently from what I thought. If it does return true, if it doesn't, so does that mean so far these are the same? It doesn't matter. We're actually checking the quality of functions. Okay, let's do C starts, no, let's do C extends results, C extends C continued. Oh, well, with extends there's always a need for, what's it? False. Okay. Okay, I'm going to try and understand something here. This is a unique type. But what makes it unique? What makes it unique versus this type? I want to break this by actually passing in equal types to C start and C continued. So I'll just pass in read only A. So now we should get true, but I want to break it by changing that, for instance, false. Okay. Okay, so we're comparing on a function level, and not just on any function level, on the type of a function we just defined. Alright, let's add this back. If I understand this, I need to ask myself, is there some other way I can... I don't understand this. I don't understand why this is distinct. Why is a function that takes a generic type and returns whether that generic type extends a very specific type and returns 1 or 2? Why is this distinct from this? What makes this a type? I'm like, what if T is actually something that extends? Okay, I think that's the question. Is it possible to have a T that extends? Yeah, it is, very simply this. Is it possible to have a T that extends both this object with the read-only A and the other object with the non-read-only A? The answer is yes. the read-only A. No. The non-read-only A extends the read-only A from correct subsets. No, isn't the read-only A a subset of the read-only A is a subset of the non-read-only A. What am I saying? So here we have the read-only A, and what we're checking is if this extends. No, they both extend one another. It's a little more confusing. They can both be subsets of one another, apparently. Okay, TypeScript, you do you. Okay. I don't think I have enough data here, so I'm probably going to need to look up more data as to why is this a symbol, and what makes it a unique symbol? What makes TypeScript functions unique? This is such a bad. Yeah, it's too broad. TypeScript function types. Oh no. Okay, let me go get my charger. Alright, I'm back. Now, function types are the basic building block of any application. By the way, there's so many possible types you can have in TypeScript, infinite, right? But functions are the basic building block of an application and the whole important. Describe, okay, type expression. Similar to describe a function is a function type expression. The syntax means a function with one parameter named a, a string that doesn't have a return value. Just like with function declarations, if a parameter type isn't specified, it's implicitly any. Generic functions. Okay, we call signatures the equality of TypeScript function types. Could be something I can look at. Why is my fan, like, there's nothing running? Why is my fan? Gosh. Anyway, the equality of TypeScript function types is a potential area I should look into. Call signatures, construct signatures, inference, working with constraint. Assignability of functions. Thank you. The void return type for functions can produce some unusual but expected behavior. Contextual typing of the return that does not force functions to return something. However, to say this is return any other value but it will be ignored. Classifying implementations are valued. And when the return type of one of these functions is assigned to its value, even though push returns. No, that didn't help me. Generic functions. This doesn't help. Equality of TypeScript. If this, is there any way I can look at this as an object? Because that would be so much easier to work with. So this, how do I see this as an object? It returns, this is a boolean value. This is the return type. On a surface level, sure, why not? Like, TXN's a property that's not read-only is different from one that's read-only, but what happens to structural typing? Why can't this type extend the other type? Why can't the other type extend this type? How do I answer this question? It's annoying. If I pass this generic type, and I just return T, and it could, if I implemented this by just returning T, returning the value that's passed as a, okay, I think the issue is I'm thinking of value space. I'm not passing any parameters to this generic function, just the generic type. I am not returning, and I'm not passing through that type. So the situation of passing in a type and just returning that type doesn't exist in this context. I'm passing in that type and I'm extending that type to see whether that type extends. That type is a subset. So this is a very huge, the set of any possible types. I'm checking if the set of any possible type is a subset of a particular type. A with non-read-only A. That's like saying, that's like asking if any is a subset of that type. Do we still get false? No. Now we get true. Amazing. Amazing. Wow, TypeScript just surprises me. So by changing that to any, it does extend X, and it also doesn't extend X. You can find types in any that do and do not extend X. So straight away it's returning a union of 1 and 2, and of course this is going to return a union of 1 and 2, and of course those unions extend each other, so this will always be true. So like the way I'm thinking about this, so T must be something a bit more specific than any. How about something like unknown? I think that we will get the same union. Oh, okay. We don't. It's much more specific. Why? I mean it to be true. It's much more specific. Unknown, what was it? I can't remember the rules for unknown. I think you can assign any value to unknown, but you can assign unknown to a type of unknown. You can assign any value, but you can assign unknown to some other type. So what's that saying? Unknown is a subset of some type. No, unknown can never be a subset of some type, but all other types can be subsets of unknown. So unknown, any object is quite broad as well, but in both cases it's going to give us true, right? Because this functions the same way as this. Why does, I guess with t it could be anything. We don't know, we won't know until we actually get a t, right? So I guess it just sees this as a type. I don't know how else to understand this right now. This is as distinct a type as 1 and 2 and 3. Is this a unique symbol? And if that's the case, can I create other unique symbols with other keywords? Can I say what other ways can I create a type that needs to be evaluated? Because I think that's what this is. If I said type of t, it will be evaluated the exact same way as here and here. If I said it needs to be a conditional, I think I can't imagine. We can't know if t extends or none. Can we know if t extends or none? We can't know if t extends or none, but unfortunately we can't use this unknown type in both cases, because then it will just be true, right? We can't come here and do unknown as well, because then this symbol is the exact same as that symbol and they'll both be true. But if we switch things around, maybe did 2 or 12 2, then they'll be false. The symbols differ. Is there some other way though that I can create a function of x and a function of y, a type that's a function of these things that's still unknown? I guess yes. I mean, it doesn't have to stop here, does it? Can we say 2 extends t? I don't even access t in negative place. 1 t extends x extends y. And then we can say 5 or 6. I don't know. So that's another symbol. Now it's a function of x and y. And we want to check if okay. Well, now we want to check if this does the exact same thing. This is an unknowable expression until we have the values of x and y. And this is also an unknowable expression, so what is x and y? But these two expressions will be equal because they have x and y in the same position, so we'll always have true. If we wanted to mix things up a bit, we could just say this is y, and this is x, and that remains x and y. These two expressions will always be different. But that defeats the purpose of an equality comparison. We want them to be the same expression when they're the same. Okay, cool. If they are the same, then these two expressions will be the same when x and y are the same. That is quite obvious. So, but here, with read-only a and non-read-only a, we will get false. But with non-read-only a and non-read-only a, we'll get true. Ooh! Oh wait, I forgot to change it here as well. We get true. I mean, I think this is the best way I can understand it in terms of when you create an unknowable expression that needs an actual distinct type to evaluate. TypeScript apparently creates a symbol based on whatever variables you put in it, and they're using that property here to create two symbols that will take on the same value when x and y are the same, but take on different values if x and y are not the same. Okay, I'm gonna stop here. I think okay, rather than just stopping here, let me change this to, let me use my own random implementation of an unknowable expression. Put that in there. Oof. Copy it instead of paste it. There. And then delete all of that. And then how we doing? Includes is using table. Let table use c equal custom equal t of t on the one hand and u on the other hand. What's the same? Expected. Oh, we don't need this anymore because that returns a boolean value. But yeah, the final thing here is if that expression extends that expression, then true, they're equal, else false. I'm curious if we actually need this outer braces. Fascinating. So yeah, I think so. Extends. Apparently we do. Well, it's quite clear why. I don't even want to dig into how the boundaries go. Yeah, I wish we could. And when you combine that with the whole function expression type, it becomes, so this is actual distinct symbol. Well, that's as best as I will be able to understand this for now. And I hope that as I experience more of TypeScript, I understand this in a deeper level. But maybe I should read into symbols in TypeScript. Maybe that's something that will shed more insight in this. But yeah, I'm glad I looked into this, and I'm glad I've added this idea of creating unique symbols to my TypeScript toolkit. Yeah, awesome. And going to stop here for now, and tomorrow I'm going to look at the next challenge, which will be, I don't know what it is, but yeah, see you guys next time.